Hi. Our main topic is today is runtime system versus compile system. Runtime and compile time. And second topic is data synchronization. Oh no, I mean process synchronization. Process synchronization. So let's begin. Um, so actually, I'm trying to make an operating system using Rust, and there's the feature in the Rust they call static. So static is just like the variable. It's just like defining variable, but you can extend this variable into class thing. So there's such a thing I'll say a static, but the problem of static is it it evaluated at the compile time. So what I mean evaluated in the compile time. So this means that it changed first time it changed into machine code and then it's executed. So to elaborate more about compiler and the runtime, think about some kind of JavaScript, right? The the feature about JavaScript is the compiler reads the first line of the code and second line of code, third line of code. And each time it reads the line, it executes it. So and it reads line by line, it also executes it line by line. But the compile time is different rather than the runtime. Compile is like it reads sorry, it reads the whole line of it. Let's see, uh, let's see. There's some fancy code in the one file. Rather than it executed into line by line, it reads the whole part of the file and it changed it to machine code and it executed. So there's a big difference of it. And the problem of this this static is it, it initialized by compile time. So which means that rather than rather than reading it line by line, executing line by line, it just compiled into some kind of machine code and executed later. And and this is and this is why you should understand what is compile time and runtime. And the more difficult is you will learn from here is when you're trying to define some kind of raw pointer in here. So what do you mean raw pointer? So a raw pointer is a pointer that you specify on the hardware level. Uh, Let me give you an example for you. When we try to print something on the screen, we can use the BGA hardware, it's just the graphic chips, and there's a specific address we should start with. So that's core 0xb8000, and we should make a pointer of 0xb8000 because we're trying to put some text on the screen, right? And we should put something on there. And but the thing is that this raw pointer thing is that it cannot evaluate it at the compile time because this character of the raw pointer is it indicates the hardware specification, right? It interacts with the hardware, and the runtime system is the one who makes that happen. But the compile time is it just changes into machine code and it doesn't know where the memory addresses are. So let me try to make it simplify for you. For example, you specified some kind of uh, some kind of Excel. So you wanna put something text or whatever number into the column one and row one, and but the compared is it just change whole thing into some kind of that we can understand. But the runtime is it executed. So which also means that this row and column is exists and we can understand by executing or reading it, right? So that's the big difference of runtime and compile time. And we're trying to make this static into some kind of a runtime. We can just do it into lazy stat. It was like, yeah, lazy static. Here's a lazy static, and that's very simple. But the problem of the making static is also related to another problem. We just code into mutability issue. You can just switch these statics into mutable, like static mutable, but it's highly discouraged is uh, because this variable can be referenced in in many line of code. Example, you specify the statics in somewhere, and your other code could reference this, and your other code could reference this, and that will cause data race. So data race, it just means like data inconsistent based on the execution of it. So we can use spin lock. So our second topic is process synchronization, and the spin lock is the type of process synchronization. Yes, so our topic is done. The first one is done. And this is the second one. When you try to learn about process synchronization, you should ask yourself, what is synchronization? Why we need some kind of synchronization? The reason why we need process synchronization is because core issue of designing of concurrent system. And the concurrent system seems like very vague, right? The meaning of the concurrent is actually doing it at the same time. But you should give more ask question about it. Is there concurrent thing in physical world? Let me give you an example about more. There's a line of it. There's a final line, and there are two athletes trying to go here, trying to be a first place. Of course, they're gonna run very hard, but they seems like enter the same time. But if you look at it closely, there's no such a thing at the same time. If you look at the minutes of it, means milliseconds of it, there should be difference of it, right? So actually, in the part of that, there's no doing it the same time in the real world, and that also really valid in the computer science world. So in computer science, concurrency is like doing the same thing, right? But actually, it is not. You're just using the process scheduler to make it like doing the same time, but it is not. Or it just seems like it. And the problem of these concurrent is when the thread, example thread, is doing it this like reference the same shared resources and trying to do something, they're gonna be unexpected value, right? And these to handle this kind of data risk, we use some kind of locks or mutases or safe words. So let me try to elaborate more about this kind of issue. There's a data race conditions. So what's a race condition? Race condition is occurred when two or more processes are accessing the shared data simultaneously, and the outcome is dependent on the time of the running process. Let me try to simplify for you more. If you look at the process and what we learned from our operating system class, the process are independent. But you should give a question about our real process are independent, but why there's something like this data race condition? Why? You really have to know that there's still shared resources, like files or those kind of things, or something. It could be memory, and we should stop this kind of the data inconsistency. And the first thing is also the race conditions. And next is priority inversion. So priority inversion is, for example, there's like the task of Fred, and this when this lower priority task or the resources that the higher priority task needed, there's gonna be priority inversion. And next is starvation. The starvation is if the scheduler algorithm always favors some of the process and over others, less privileged process may never get the CPU or other resources required. So so this is a kind of the problem of the current system, right? And to solve this issue, we use process synchronization tools, which is locks. So locks for multisys, mutual exclusions. It's just making us to use one thread or process at the same time. And of course, there can be deadline of it. I'm just gonna elaborate more later or tomorrow. And there's another called the semaphores. So semaphore is just like regulation that how many processes can simultaneously enter a critical section of the program. So and next is the monitors. Monitor is a synchronization mechanism used to allow separate processes to share resources safely without interfering with each other. And spin lock is it's just like rather than making Fred to sleep, it's just making a thread spinning like active, and it handles those those kind of issue of it into multi-thread about environments. So this is it. This is really simplified of the process synchronization, and but the thing is that what I'm trying to do is making this data synchronization tool from the scratch. I already know what is happening under the hood. What is a thread? What is a process? How can I make thread or process, right? So that is what I'm trying to do. It could be hard, but I'm pretty sure it's worth to dive into some kind of complex problem, which is making something from scratch. Because these are the operating system, we are computer science, and we should learn about this kind of operating system. Because operating system or computer science knowledge is fundamental of the engineering, right? So this is it. Bye bye.